To build or not to build? Should I construct a rainwater catchment system? By Katia Osei and Lilliana Brandao.
So just a little bit about what this presentation is about. We're going to be talking about what a rainwater catchment system is, how we can build rainwater catchment systems, and then how we should decide if we should build either of the two rainwater catchment system options. So a rainwater catchment system is also called a rainwater collection system, and it basically just collects rainwater and stores it so that humans can use it. They can vary in how elaborate they are. Some can be more simple, like just a rain barrel, or some can have more components and be like structures built on a house or other building.
There are two types of rainwater catchment systems. A roof catchment system where the catchment structure is built on the surface of a roof, and a ground catchment system where the catchment structure is built on a piece of land. Now we're going to talk about the roof catchment system. For this presentation, the construction of a roof catchment system has been divided into three parts: the construction of the catchment structure, installation of gutters, and construction of a means to dispose of the foul flush. The construction of the catchment. Before constructing the catchment structure, check that the roof is strong enough to support this catchment structure. You can use tiles or metal sheets to build this catchment structure. The catchment structure should not be built on lead or painted roofs, as this could contaminate the water. You begin by placing the roofing material on the roof, starting from bottom to the top. Overlap the roofing material to prevent leaks. In case there are leaks, seal the holes with tar. Now, gutter installation. The gutters are installed to collect water from the roof catchment surface and direct them towards the tank. They may be made of bamboo, plastic, wood, or metal. As shown in this diagram, the gutters are installed on both sides of the catchment structure. The water flows down the catchment structure into the gutter. The gutter directs them towards this other pipe called the downpipe or downspouts, which directs them to the cistern or tank. How to connect the gutters to the downpipe. They are connected directly. The downpipe may be connected directly to the end of the gutter as shown here, or connected to a hole through the gutter as shown here. Either way, a mesh wire must be placed over the joint to act as a sort of filter, preventing materials such as leaves that may be in the water from flowing into the tank. The joint is then sealed with tar or caulking powder. Foul flush disposal. What is foul flush? Foul flush refers to the first runoff from the roof after rainfall. We do not want to collect this water as it may be and is usually contaminated. How to get rid of foul flush. If the system is simple enough and the downpipe is flexible, you can pull the downpipe and direct it away from the cistern, allowing the foul flush to flow directly onto the ground. After a while, you pull the downpipe back to its original position, so clean rainwater is then directed to flow into the tank. Alternatively, if the system is more elaborate, a foul flush system may be constructed, which may consist of a small collection box to collect the first runoff, or a whole filtration system. On the right, we have the filtration system, which is made up of pea gravel, charcoal, sand, and gravel. This filtration system prevents impurities that we don't want in the water, such as silt, from getting into the tank. Now on the left, we have the system that collects the foul flush and then allows only cleaner water to flow into the tank. As shown here in the left picture, the sediments settle at the bottom of the tank, allowing only clean water to flow into the tank. The ground catchment system. This is just composed of a catchment surface on a piece of land, which directs rainwater into a tank as shown below. The tanks are usually underground. The catchment surface. The catchment surface must be impervious, and thus compacted clay surfaces are preferred. The soil may be treated with chemicals such as sodium salts, which makes the surface even more impervious by breaking the soil particles into smaller particles so that they fill the holes in the ground and then prevent the water from leaking through the ground. Alternatively, cement, asphalt, or polyethylene sheets can cover the ground to make it more impervious. How to maximize water collected. To maximize water collected, you can make the collection surface larger. You can make the collection surface area larger. You also make the surface more impervious, as discussed in the previous slide. Also, the steepness of the land should be increased. The steepness of the land increases the rate at which water flows down the surface into the storage tank to reduce time water is exposed to the atmosphere, and hence it reduces evaporation of the water. If done correctly, a ground catchment system can be very effective. For example, if the catchment surface area is 15 meters by 50 meters and annual rainfall is 100 millimeters and the efficiency of the system is 80%, which is about the efficiency of a roof catchment structure, the amount of water collected in a year is 200,000 liters. That is about 555 liters per day. Storage. In areas with irregular rainfall, the tank should be as large as possible so enough water is stored to last even during dry periods. Before the water gets to the storage tank, there must be some system to filter the water before it reaches it. This can be a silt trap as shown here, where silt and impurities settle down, allowing cleaner water to flow into the tank. Alternatively, a filter system similar to the one discussed in the roof catchment system, made of sand and rocks, can be used to filter the water.
Okay, so just talking a little bit about location of rainwater catchment systems and things we should consider when deciding where to put them. We want to make sure that it's somewhere with sufficient rainfall because obviously if there's not enough rainfall coming down, then it might not be worth it to put money and effort into building this system if there's not going to be enough water to sustain the people needs to. And then roof catchments cannot be put in most places, on most buildings, which is good because it's easy to find places to put them, but it's important to make sure that they don't have anything on the roofs like lead or any of the other like paints, like Kat had said earlier, which is something we should consider and make sure that it's safe and that nothing will contaminate the water. The catchment site should also have enough space for some sort of storage tank because the size of the tank depends on rainfall patterns. If there's more rainfall in an area, you don't need as big of a tank because water's going to be coming in more frequently. But if there is less rainfall, then it's important to have enough space for a larger tank so that water can be collected when it does rain and so people don't run out. And then for ground catchment, like Kat said, it's important to have impervious surfaces such as clay. And even though other surfaces can be chemically treated or they can be covered with impervious surfaces, that's not ideal because it might be expensive to do these processes and the materials needed might not be available in the local community. So it's best to just find somewhere that has clay or some other more impervious surface naturally. It's also really important to consider property ownership along with who's going to be using the water collected at the rainwater catchment system. If this is a catchment system that will be used by the whole community, it's important to make sure that the community has permission from the landowner to use this whatever building or other land for the rainwater catchment system. So yeah, just considering like who owns the land and who's going to be using it on a regular basis and making sure that everyone's communicated well. So whenever we're going into a community and deciding if we want to construct a rainwater catchment system, it's really important that we do some various data collection and calculations to make sure that we're fully prepared and that we can design the tank and system as best we can. One of the most important things to look at is the water demand, which can be measured in liters per person per day. Data for this can be collected from community surveys usually, just by going in and asking people how much they use, which can be a bit of a difficult process, but I know we've been working on that a lot in our team, is seeing how we can find out how much water people are using to make sure that the system would be able to sustain enough water for everyone. It's also important to look at water supply, which is just how much rain is coming into the system. This can be done using an 18-month analysis of the monthly rainfall patterns, which I'll talk about a bit more on the next slide. And then having the water demand and water supply, we're able to calculate the size of the tank needed to collect enough water to supply that water to everyone. And then we can also look at the gutter sizing and finding out how big those gutters need to be to have all the flow of the water coming in. And then it's important to also do structural calculations to make sure that the tank and the system are capable of holding all the water that it's going to be going in and through it, and that the system is going to be able to withstand any environmental stresses. It's also important to look at the availability of materials to make sure that everything we need, such as tiles, cement, pipes, the cistern or tanks, are going to be available in the local community for a reasonable price that is within the budget of the project. So this is a data sheet that we can use from EWB-USA to do these various calculations needed to design the rainwater catchment system. As you can see here, it has roof area, the runoff yield, first flush, tank volume, yearly rainfall, daily demand, and so all of the information that we need. So this could be really useful for if we're ever going to be actually collecting data to create the rainwater catchment system in a community. And here you can see part of the 18-month rainfall analysis. It just shows like the month, the days per month that it rains, and then the rainfall in each of those days. So this would definitely be a useful tool in the future to make sure we have everything we need in order to design the rainwater catchment system.
Okay, now how to decide when to build what? For the roof catchment systems, materials are almost always available in the community. They can be installed in most places and have a relatively simple design. They are also relatively inexpensive, efficient water collectors, and easy to maintain. However, to collect enough water for a community supply, a building with a large enough roof surface, which might not always be available in a community, is needed. In addition, it is only practical in areas where rainfall is abundant and fairly evenly distributed throughout the year. On the other hand, a groundwater catchment system collects larger amounts of water than the rain catchment systems, and thus it can provide large quantities of water even during dry seasons. However, they are generally more expensive to make because of the cost of labor and materials, and greater skills is required for construction.
And then here we have our work cited, where we got all of our information. If you need to look into anything with more detail, definitely check out these sources. And yeah, thank you for watching.